Intermediate value theorem, a very important theorem in the study of analysis, and this is Introduction to Analysis. The intermediate value theorem simply says that if you know that you have a function that's continuous, secondly, you know that the function is continuous on some closed interval from a to b, thirdly, you know that the function values at the endpoints are different. And if k is any number between the so-called function values of f of a and f of b, then there has to exist at least one number, c, on the closed interval from a to b, such that f of c is equal to k. A very simple conclusion, but most profound. In the study of mathematics, we talk about certain theorems, the classification of theorems. And here, this is called an existence theorem. We talk about an existence theorem that simply says that something exists, that a certain value exists, a function, or sometimes even that a certain neighborhood or interval exists given certain parameters. An existence theorem does not tell you how to get such a quantity. It just simply says that the certain value that you're seeking for based on the preliminary composites of the statement, here a theorem or even a definition, it just simply says that the value exists. And in terms of how you get that value, it requires other means. I said that the existence theorem is one classification of the way we classify theorems in mathematics. I'll just give you two examples. A second example is called the uniqueness theorem. And the uniqueness of a particular function or vector or system simply means that if you find the so-called solution, then if it's unique, then that particular phenomena or system only has just that one solution. There are no other solutions out there that are different that would suggest to be a plausible solution for the particular function or system or whatever you're studying. One of the neat applications of the existence theorem, I think, is that here in this intermediate value theorem, that you can use it to find the so-called zeros of a function. A zero of a function is simply where the function crosses the x-axis, and that x-axis, on the x-axis, that value that you get where the function crosses it is said to be the zero. Well, here's what we say, that in terms of how to apply the intermediate value theorem, if you're looking for a zero in certain functions, it's difficult to find the zero, and you can use various methods, Newton's method, to find the so-called zero, other methods out there that you can use to find the zero of a function, computers or graphing utilities. Well, Runge Cutter is another that we use, or least square regression is another. But you don't have to use anything that difficult to find certain function zeros. So anyway, you're looking for the zero. Didn't mean to get on a tangent. You're looking for a zero for a function, and you know that the function value, the function changes values from negative to positive or from positive to negative on the interval from a to b. So if you got a graph, and if this graph, say for example, So the function, the graph is in blue. You're looking for this so-called zero, right? We're looking for that zero. In order to find it, we can apply, first of all, the intermediate value theorem to say that such a value, that particular zero, exists because notice that to the left of this point, the function values are positive above the x-axis. And then to the right of this point, the function values are negative. Right, we have a graph down below. So if the function changes values from negative to positive or positive to negative, then that indicates that there is at least one zero on that interval, some interval that you may be examining, right? So if that be the case, we want to apply the intermediate value theorem to work the following problems. In exercise 95 and 98, verify that the intermediate value theorem applies to the indicated interval and find the value of C guaranteed by the theorem. Right? Well, number 95, the function is continuous. You can evaluate at f of 0. That gives us -1. And then f of 5 is 25 plus 5 minus 1 is equal to 29. So the main thing there is that f of 0 is not equal to f of 5. And so what this says is that there exists a C that's on the interval from 0 to 5. That is, that 0 less than or equal to C less than or equal to 5. That's what that means. So if that be the case, then we just set the function equal to 11 and we just change the x to C and just solve for C. So here what we have is f of C is equal to C squared plus C minus 1. That's equal to 11. And here we have C squared plus C minus 12 is equal to 0. Well, we can factor. It looks like a 4 and a 3 plus and a negative. We get C equal to -4 and C equal to 3. But the value has to be on the interval from 0 to 5. So that will exclude C equal to -4. So the value that you want is that C is equal to 3, which is indeed an element of, or it's on the interval from 0 to 5. Consider number 96. So I'm just going to cut right to it if you don't mind. I'm going to set f of C, which is C squared minus 6C plus 8 equal to 0. Can we factor that? 4 and 2. Looks like they're both negative. And so we have C equal to 4, but this is not on the interval from 0 to 3. And then we get C equal to 2, which it is an element of or on the interval from 0 to 3. So only that value there that we have highlighted is the answer. Number 97. So we have f of c is equal to c cubed minus c squared plus c minus 2 is equal to 4. And we get the 4 on the left side, so we get c cubed minus c squared plus c minus 6 equal to 0. Something like this, I think an easy way to solve is to use synthetic division. Take the coefficients here of the polynomial, so that's going to be 1, -1, 1, and -6. And you look at all the factors of the -6 to look at possible roots. So all factors of 6, that is rational, that is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So let's say, for example, if we try 1, you always, for synthetic division, you bring down the first term 1, you multiply 1 times 1, you get 1, you get 0, 1 times 0 is 0, 1 plus 0 is 1, 1 times 1 is 1. Here we get -5, but we don't get 0, so that doesn't help us. We want to get 0, and if you get 0 here, that means that this number, or the term x minus 1 or x minus c, is said to divide this particular function, right? So can't use that. So we try another factor. You got all these factors, possible rational factors. Again, 1, -1, 1, -6. Let's try 2 this time. So bring down the 1. 2 times 1 is 2. -1 plus 2 is 1. 2 times 1 is 2. 1 plus 2 is 3. 2 times 3 is 6. -6 plus 6 is 0. Booyah! Yes! Okay, so that works. And so the value that you want would be c equal to 2. And is it on the interval from 0 to 3? Well, yes, it is. So c equal to 2, which is on the closed interval from 0 to 3. So that's what you want. Okay, the last one. We set the function equal to 6. So here we get c squared plus c. Why is it moving by itself? I didn't do that. I'm going to get up here and run out of here because it's getting spooky when things on the computer is moving without my control. But anyway, it's a philosophical statement. But anyway, this is divided by c minus 1 is equal to 6. I hate writing with the c's. I'd just rather use x. Y'all want to do that? Is that okay? Okay, thank you. I heard that. So just going to get rid of, see, that thing jumped over there. So I'm just going to say x squared plus x all over x minus 1 is equal to 6. Multiply both sides by the x minus 1, so we get x squared plus x is equal to 6 times x minus 1. This gives us x squared plus x. This is 6x minus 6, so add 6, or minus, subtract 6x on both sides, and add 6 on both sides. So we get x squared minus 5x plus 6 equal to 0. Factor x minus 2 times x minus 3 equal to 0. So we get x equal to 2, and then we get x equal to 3. Let's look at the interval. The interval is the closed interval from 5/2, or 2.5, to 4. This is not on the interval of 5/2 to 4. This is on the interval from 5/2 to 4. So x equals c, or x equal to 3, or c equal to 3, satisfies the intermediate value theorem. Thank you.